We're going to look at applications of rational functions. We'll start with the review. For the warm-up, list any vertical and horizontal asymptotes of the following function. Well, for the vertical asymptotes, we look at the denominator. Well, actually, we should factor this first. So if we factor the top, we can factor 3 out of the first term and the second term. So we'll get x squared plus 2. And on the bottom, of its difference of squares, so we get x plus 5 and x minus 5. So for the vertical asymptotes, you take a look at what makes the bottom equal 0. So the vertical are x equals negative 5 and x equals 5. For the horizontal, we take a look at the highest exponent in the top and the bottom, and we get 3x squared over x squared, and it's y equals. The x squareds cancel, so the horizontal is y equals 3. And then if you were to graph that, if these were our axes right here, here's x, here's y, you would have a vertical asymptote at negative 5. You would have a horizontal at 5, another vertical at 5, sorry, and you would have the horizontal at y equals 3. Applications of rational functions. You and your friends go to IHOP after the homecoming game. The total bill comes to $150, including tip. You decide to split it evenly since you all don't want to get into an argument. A, how much do each of you pay if there are 18 people? Well, you split it, so you're going to divide by 18. So we'd say y equals 150 divided by 18, and each of you would pay about $8.33. How many would each of you pay if there are 25 people? Well, y equals $150 divided by 25. The more people that there are, you're going to pay more or less. Well, you're going to pay less if you're dividing by more, so you pay about $6. C, write a function c of x to represent the amount each person has to pay given x people. So c of x equals 150 divided by x, or how many people there are. What's a reasonable domain and range for this situation? So remember, domain is the number of people, and range would be the price that you pay. So c of x and people would be x. So if you think about that, people can't be negative. People probably wouldn't be 0. So I would say that x is between 1 person and, in this situation, 25. But I guess it could depend on how many friends that you have. So I'll put 25. Unless you have more friends, you could put more for that. And the price, c of x or y, is either going to be 150 at most if there's just one of you, all the way down to something that approaches 0. It would probably be greater than 0, so I probably would change this. Depending on how many people there were, you could pay not that much if there are a lot of people. Although if there were 25 of you for our max right here, then we could say that the minimum price that you would pay would be $6. So if I define my domain as 25 people, then the least amount that you would pay would be 6. Graph the situation on a calculator. Change your window to reflect your domain and range by pressing Menu, Windows, Zoom, Window Settings. Sketch this in your notebook. All right, so let's pull up our graph here. Excuse me, I wanted to open a graph page on this. Sorry. New document, add a graph. All right, so let's type in our function. F of x equals 150. Excuse me, divided by x. And let's change our window by going to Menu, Window Zoom, Window Settings. And again, we said our minimum would probably be 0 or 1, but we'll put 0 to excuse me, how many friends we have. So let's just say we had 25 friends. Oops. And the minimum, we'll just put 0, but it'd probably be like $6 if there were 25 of you, to maximum 150. You could go a little bit higher. Let's go a little bit higher. All right, so there's our function. You can see that the fewer people there are, the more that you pay, and the more people, the less that you pay. So sketch that function. Okay, let's do that. So this is x, this is c of x, or cost. This is people. Excuse me, this was 200 up here. And if we sketch that function, well, there's what it looks like. What are the x and the y-intercepts, and what do they represent? Well, the x-intercept would be along here. We don't know what it is. And the y-intercept would be along here. So the x-intercept would be the number of people that pay $0 because it would be free. And the y-intercept right here would be the total cost, because here's 0 people, so this would be total cost. Total cost is 0 people paying. Describe the shape of the graph in terms of the scenario as the number of people, so here's the number of people increases, the price of course is going to decrease. So there's a rational function. 3 of your friends leave before paying their portion. How would we change this function to match the scenario? Well, we have our cost of x is 150, and it was divided by x, but now 3 people are leaving before they pay, so x minus 3. Predict how this will change the graph. Well, if it's x minus 3, does that move the graph up, down, left, or right? We know that if it's minus 3, it moves the graph right. Sketch the new graph below. So if I take a look at this graph right here, it's going to move it 3 to the right, so it's going to take longer for it to cost less. So actually I'm just going to sketch it right on here. So tab, same in that function, 150 divided by, and x minus 3, 3 less people pay. So there you can see it shifts 3 to the left. Predict how this will change the graph. 3 to the left, sketch the new graph below. Okay, we took a look at what that looked like. Here's what it looks like. It shifts everything over because now it takes longer for it to cost less if 3 people don't pay. Because your waitress was so nice to the group, you decided to each give an extra $2 tip. How would we change this function to change the scenario, or I should say to reflect the scenario? We would say c of x equals 150 over x, and each of you are paying $2 more. So if this is the cost per person, it'd be whatever 150 divided by x is, but then plus 2. So we know that this moves the graph up
With the following
2.
people report to A203 for an IEP meeting: Brad Brubaker, Julie Conrad, Jeff Cohen, and Amanda Forsberg.
Does this change your domain and range? Well, up 2 changes the y value, so that changes the range. Sketch this new graph below, so it changes the price. Sketch the new graph below again. I'll just reflect in our graphing calculator. So I'll just hit tab. And we have, I'll do the 150 minus x, or divided by x in parentheses. And then plus 2. It's going to increase the cost. So you can see how the black line is increasing the cost up 2 each time. So really it's, in this graph it doesn't show up. That's a huge difference, but it'd be $2 more per person. And it increases the amount of money that you pay. Did your vertical or horizontal asymptote change, and why? So if it's up 2, then it changes our horizontal asymptote. It shifts that up 2 as well. Okay, last type of problem is a drug problem here. The function C of t equals 5t over 0.01 t squared plus 3.3 describes the concentration of Tylenol in the bloodstream over time. C is measured in micrograms per milliliter and t is measured in minutes. Calculate the amount of Tylenol in your bloodstream after 3 minutes. How did you calculate this? So where does the 30, the t go? Or the 30 go? It goes in for t or time. So we would say the amount in our bloodstream after 30 minutes is 5 times 30 over 0.01 times 30 squared plus 3.3. You put that in your calculator. Again, hit enter before you divide. I put this in parentheses as well. And I did that ahead of time. And what did I get? Let's find my notes. Okay, so there it is. It's about 12.1951. And it's measured in milliliters. Okay, so milliliters. Calculate the amount of Tylenol in your bloodstream after 60 minutes. So this is for 60 minutes. We have 5 times 60 over 0.01 times 60 squared plus 3.3. Again, I would put the bottom in parentheses here. And do you think the amount in your bloodstream is going to go up or down after 60 minutes? It actually goes down. It's about 7.633, 6 milliliters. I should put the wavy lines for about. Calculate the amount of Tylenol in your bloodstream after 120 minutes. So again, it's probably going to go down as it leaves your body right here. And I've calculated it for after 120 minutes. It did go down. It's about 4.073 milliliters. Sketch a graph of the function over the first 2 hours after the dose is given. Label the axes. A good window is from 0 to 180 and y is from 0 to 20. You can use the table feature Control-T for a more accurate sketch. So let's pull up a new graph here. Okay. So if we type this in, again I'll use parentheses. So we have 5x divided by parentheses, we have 0.01 x squared and then plus 3.3, and again we can only see part of the graph, so let's change our window. Menu, window, zoom. It gave us a good window setting from 0 to 180 minutes, and the maximum was for about 20 milliliters. Whoops. Oh, that's our minimum. So let's go from amount 0 to 20 milliliters. So you can see we take the drug, it enters our bloodstream, but then it starts to leave our body right here. So there's a good picture of what it looks like, and you can sketch that function on your graph. Oops. So sketch it here. Determine what the maximum amount of drug is in the body and the amount of the time. You can use the calculate max feature, so we know it's somewhere around here. So if we go to menu and analyze our graph, let's find the maximum. Define your bounds here. So the maximum is 18.2, 13.8. So let's write that down and talk about what that means. 18.2, 13.8. So there's the max. The maximum. Let's talk about what the meaning is of this. So this was time in minutes, so 18.2 minutes. The maximum amount of blood in our bloodstream is 13.8 milliliters of the drug after 18.2 minutes. Okay, explain within the context of the problem the shape of the graph. What does the graph communicate between the max point and 2 hours after taking the drug? Well, it means you take the drug and it absorbs in your bloodstream, and after 2 hours, you can see it starts leaving your bloodstream. What are the vertical and horizontal asymptotes of the function? Okay, so the horizontal asymptote, grab this, let's do a color, dash lines. The horizontal asymptote would be 0. You can't have negative blood in your bloodstream. And the vertical asymptote would also be 0, and we should write them in. This would be x equals 0 because x is time. Time can't be negative. And the same thing for the y equals 0. The amount of drugs in the amount in your bloodstream can't be zero. Be
Cassandra
negative.
Rios to the counseling office. Cassandra Rios, please come to the counseling office.
So our asymptotes exist to show us that time can't be negative, and also the amount of blood in your bloodstream, it can't be negative as well. So you're going to practice problems like these for your assignment. Also, if you have any questions, you can let me know during class or look back at these example problems.